Welcome everybody to today's HPC Cafe. The title is how on using the CX services based on the RRZE GitLab instances with the help of the NHR FAU systems. So the idea is to run the tests and so on our HPC infrastructure. This is basically the section from the FAQ corner that Georg mentioned. So these are the four main continuous or CX words you will find in the wild. Continuous integration is basically download everything, build the dependencies, build your code and run some tests. But it's more focused on building it, less on the testing side. For testing, we have continuous testing, which is continuous integration with tests. Continuous benchmarking is continuous integration, then doing some testing, and in the end doing some benchmarking, so get real performance numbers of the code and to see whether you had introduced some performance degradations by your code. So if you add something new to your code and you run it there, you can see directly whether it's working or not. You still have better, the same performance, better performance, worse performance, so on. And the last one is continuous deployment. Basically, when you did all your testing, you set up some kind of package and push the package to some install, to some index like PyPy, or install it on a specific system, like add a new module to our module system, things like that. That's all continuous deployment. So this is a recap from a previous talk we did in the HPC Cafe about Git. I just copied out the why CX slide. So why do we need that? If you're building bigger software projects with a lot of backends that are like optimized for architectures, different architectures, it's tedious to test them by hand. So CX is basically a tool to compile it on different machines, to test it on different machines, and to test different outcome of specific stuff. Unit tests are we producing the correct results? This is very important. So if you're setting up, building some kind of software, please start writing unit tests directly at the beginning. This helps in the whole development process when you have tests already at hand. Coverage is if you write code, is it used at all in one of the tests, or is it not used? So if you have some if construct added to your code, if this branch is never used, then the test does not work for you. Linting is like getting some well-written code in the end. So it's formatting the code or showing you where you have formatting problems in your code, and deploying to production. It's basically free, so it comes with most development platforms. GitHub has CX, GitLab has CX, but also Bitbucket and all the other vendors on the market. It helps you to find bugs earlier. I had that case recently that one of my dependency libraries changed the API. And since I'm doing like an automatic testing, as soon as our admins installed the new version of this dependency, the CI wrote me a mail that this one does not work anymore. So I directly find the bug. Then it encourages the test-driven development. That's basically the unit tests part. As soon as you have unit tests, you can check your code while you are writing and programming. Find regressions. And also helps contributors to get engaged. So if somebody does not have such a system but wants to contribute, and you have such a system in the CX, he can write his code, commit it, and the CX will test it for him. And normally you have some kind of standardized environment. This is a little bit different in our case. Commonly you use some kind of containers or virtualization platform to encapsulate the jobs. This is not done in our case. So for us, you're running on the bare metal hardware. And that's why you of course you have some standardized environment what we provide on our systems, but it's nothing compared to like a container or whatever. Okay, so what is required for you to use the NHR FAU CX services? At first, the project must be hosted on one of the two GitLab instances. One is gitlab.rrze, which has enterprise features and can be used for FAU internal projects. So everybody with an FAU account can use gitlab.rrze. As soon as you have some projects in the German European research community where people need access to, then you can use the gitos.rrze. That's the open source license, and that's why it's limited in the feature set. If you really need the enterprise features, use gitlab.rrze. I will show you how to use that even if you have your code on a different vendor like GitHub. You need a valid HPC user account at our center. So this is quite straightforward. Just look at the page, fill out the forms, and you get a user account. Moreover, you need a separate SSH key without a passphrase. So this is used under the hood by the CX system. Yep, there's a question. The GitLab RRZE is different from gitlab.cs, yes. I think the license is different. Yeah. Okay. So this is a link. You can click on it and get to the default documentation page, how to create an SSH key. This is like the short one I used when I set up the CX services. The recommendation is to use a separate one just for the GitLab CX stuff. Don't use your default key pair. So if you run that, you get two keys, the private key and the public key. And you need both of them for setting up the system. So the first thing that people come up with is like, I'm not developing on GitLab or on our GitLab. I'm developing on GitHub or gitlab.com. How can I use the CX services? And for that, the enterprise version has a feature which is called sync for CI and CD. That's what you could do, and that's what I did with my project, which is hosted on GitHub. And all development is happening on GitHub, but I use the GitLab to run the CI stuff. So for GitLab, use the enterprise version, so gitlab.rrze, create a new project, and this run CI for pipeline for external repositories, create an access token at GitHub, and so on. I will do that now so that you can see it in live. So that's the main Liquid project, but I'm using a different one for this demonstration here. At first, I need to go here. So this is the project page at GitLab. So if you log in, you basically get a list of all the projects you have access to. And to create the synced repository, go here to the new project repository. And then you have here the big button, Run CI for external repository. If you click that, you get a page to configure the synchronization. Since I'm using GitHub, I'm using this wizard for that. So what I need is a personal access token. So let's create that. I have a slide set with screenshots that shows all the ways here that I do now, so that you can download even if you don't have the video at hand. We provide both slide sets at the GitHub, at the HPC Cafe page. So here we create a new token, whatever. Important is that with this time you set here, it's also the time that GitLab is able to sync the repositories. So if I use this token now for syncing, the GitLab can only access the repository for 30 days. So the idea is to use no expiration, although, yeah, it's not what you want normally. You can also use some very high date, some days, some years, whatever. And you need the repo scope. And with that, we go to generate. Now you have here the token. So we copy that one. And there's this copy icon. Then we copy it here on the GitLab side and do authenticate. So now the two systems are talking to each other, and we get a list of all repositories that my GitHub user has access to. It's quite long, so I will search for the machine state repository here. There you can select where to sync. So if you're in a group and you want to have the whole group to have access to or assigned to the group, you could change that here. I'm using just my user account, whatever I did there. And then it started to import it. You can wait here on that page, but it will take like tens of minutes until it writes here importing finished. So after some time, you can just go to your projects, to the list, and you will see it's already there. So it's still here. Oh no, it's here. Now it's here complete, and should go to the project. So let's close that one. So here we have now a sync project. Here we see it's mirrored from this repository, and everything, when we do a change on the GitHub side, GitLab is getting notified about that and syncs again. So let's go back to the slides. Any question till here? Okay. So there are some recommendations I could do on the work I did with the synchronization. For me, the GitLab repository, so what I created right now, is just a read-only copy. I don't do any changes in that repository. All the changes I do are on the GitHub side. This enables that if you have the syncing, it's not really bidirectional. It might cause some problems, and you cannot sync it back and so on. So this is my recommendation. In the end, if you configure everything, you will see that on the GitHub side, so this is a screenshot from GitHub. Now here, the liquid repository, you will see that this Gitlab ci.rrze is notified here and listed here, and also shows you the outcome of the CI run. So there's some integration going on, and you could see on GitHub when there's a problem. I can show some repositories that do it like that. You can also do that all with GitOS, but it requires manual work. I will publish a way to go on the HPC documentation pages, so you can find it there. This description should be there already, how to sync. Okay. At least at that point, you should write an email to hpcsupport@fau.de with the repository URL, your HPC account name you use for the CX, and the public SSH key. Yeah, we have created this pair. The public one is what you send. Don't send us the private key. Yeah. And here again, the advice: don't use your normal SSH key because others might be able to log into your system with your account as soon as they have the SSH key. So this is a security measure to do a separate SSH key pair. I have done that already for the machine state repository, or I can add it myself. So I don't have to write an email yet at the moment, but this is the way to go. They will add it and answer you back that it's now able to, you can now use it. On the repository side, you need to configure how to use or where to run the continuous integration stuff. For you have to activate the shared HPC runner, add some variables, and create the Gitlab Ci.yaml, which is the central configuration file for the whole CI stuff. Yeah, I will show that now, and also in the slide set. The shared HPC runner is also available on GitOS. Yeah, both are supported. So let's go to the repository. Yeah. So we go to settings, CI/CD. There we have the runners. And there is the HPC runner listed. So we enable that here. That's all. Important is that we need this test cluster tag in our jobs. I will come to that later. And then we have to add variables. So one time the HPC user, the CX should use. That's another question. Yeah, just so thanks. And then I have to copy my private SSH key, so don't look. Yeah, I cannot see that. Wait, can I look at that? Ah, yeah. So I'm getting the key from another repository. Yeah. So we add it here. No, don't add variable. It must be named auth key. Just paste it there. Be aware that everybody who has maintainer status in this repository, you can see that in the members field here. So I'm the only member, so no problem. But everybody with the role maintainer can see your private key you added here. So be aware of that. The recommendation is to create this GitLab repository just for one user and use it just as a read-only copy. Don't do anything there. Don't add users. Nobody needs to have access to this repository. It's only for the CI stuff. Okay. So now we should have everything ready. And now we have here the CI. And it gives you some hints how you create your own GitLab CI for already some kind of projects like Julia project or a LaTeX project and so on. But I will come to the YAML files in a minute. So as I said, all maintainers can read the variables and it's your private SSH key. If you use a separate SSH key, so as I recommended, nobody will have fun with this SSH key. So you cannot log into an HPC system with it, and so on. So it's not that error prone, but be aware that private keys should not be read by anybody else than you. Okay, so here that's the basic topology. It's a pretty, it's a visual slide, but not that informative. So here is an example GitLab CI. We define a job. We set the tag, the test cluster tag. That's what is denoted on the runners page. So we've shown in the GitHub CI settings that there is this tag, and we have to specify that. If we run that now, with some script, it would end up on the node finally. So finally is the default node. If we want to have some different node, we can define that as variable, define slurm node list and some name of the node, and then the runner will run it on Medusa in this case. So the Gitlab CI file is the central management file for Gitlab CI. You can include other files, but this one must be present in the root of the repository. As you can see here, so source and so on, the make file, and directly here we have the Gitlab Ci Yaml. The contents are, there are a lot of possibilities you can do in this file. Sorry. But basically you define and run scripts and jobs, include other files that are Gitlab CI compatible. So same other jobs, definitions or so on, you can include them. You can control whether a job can be executed in, only in serial and or in parallel. So that's the parallel is basically the default case. And if you configure deployment, what you would basically do, you define a set of pipelines and a set of stages. And in this matrix, you define own jobs. So you can define 2 jobs in the build stage for pipeline 1, but only a single one in pipeline 2 in the build stage, and so on. You can create your own stages. So you're pretty free to do whatever you want, but that's also like getting complicated in the end. So here is our first Gitlab Ci YAML file. I'm using a slightly different one in the demo, but that's basically it. If we have some variables, we can define global variables on top. Here in that case, these are the default variables that we set in the CX system. So the default node is finally, and the default time limit is 2 hours. You can define own variables inside the job that override these global variables. So you can add them, you can omit them, it's up to you. This basically runs make and run tests on some test cluster node, in our case, the finally node. My recommendation is to use the Gitlab CI editor. It has an editor to write these files. It does some syntax checks and informs you if there's some other problem in your Gitlab CI file. Here in the bottom, I have a link to the official Gitlab CI documentation. But as long as you stick to these simple jobs, I think I have enough explanation for that in the slides. So let's go and create our first Gitlab CI. So we go here to the editor, create a new pipeline. This one is not needed. And here you see already, it adds already some kind of comments and stages here and jobs. We delete that everything. And here I have prepared Gitlab Ci YAML. That's basically like the first one, just the 2 commands are different because the repository I cloned or I synced has no makefile and no run tests. So this is basically it. So we copy that here. Here it gives us shows us that the configuration is valid. Now we commit it. You should normally do that on the GitHub side. So you do it on GitHub. GitLab syncs it to the local GitHub and runs the pipeline. That's the way to go. Because as soon as you do some changes here in the repository, it might break the sync. So here we see already it ran the pipeline and we got a green mark. So we can check in that job we created right now. And we see a lot of output that's created by machine state. Here we see we are running on node finally. That's basically it. It checks out the repository and then runs the 2 commands we have given in the GitLab CI script. Yeah. In the end, job succeeded and the cleanup is done. So everything nice. So let's go back to the slides. So as I said in the beginning, the build system or the system you are running your jobs in is your basic shell you also get if you SSH to that node or you SSH to one of our nodes. So there's no containerization. You don't have root privileges to install stuff. And also the scripts can access all file system that can be accessed by the user. So the home, the $work, and so on, that all can be accessed during the jobs. That might be helpful, but also could cause some problems if you don't have your hand on the CI stuff. This is an advice I can give, since the CX services run on our test cluster, and the test cluster is made for playing around and doing research. And it might be that the BIOS or OS settings are changing without notice. Normally you get some kind of notification if you log into it manually or interactively. But since in the CX service you don't see that commonly, just be aware that this might change. Yeah. You can use modules inside your job, as I did in my first GitLab example. I used module load Python. So it uses the Python module, the default Python module on our system. You can also install dependencies inside your users directory. So pip for Python packages or Python package index, something like that. You can install as a user. If you do that, everything is fine and will place in your home. The recommendation is to clean it up afterwards in the after script section. So if you have a script section, there's also a before and after script section that can be run in before and after the script, the actual test script. The best practice I do is I install every dependency under the CI project here. That's a directory only for this CI run, only for this CI job, and therefore it is cleaned up in the end, and you don't have to worry about and like uninstall the Python package you installed with ---- user. We are planning to use spec, so there is also the user spec module already on our systems. We are trying to extend that, and this will help users to use user local installations in the future. No question. Okay, so the background why I started with this whole continuous integration thing on our system was that with Liquid, so the software package I developed, it's very hardware specific, and I need to test different hardware architectures to see the outcome. That's also quite common for HPC codes, which are optimized for specific hardware features, like here AVX 512 or a normal AVX2. So if you need some specifics like that, you can have problems in normal CI systems because you cannot tell which system you want, or are limited in the selection of systems. For us, you can select whatever architecture you want to have that's available in the test cluster, so even ARM nodes and so on. So this is the second GitLab CI, which defines 2 jobs instead of 1, and we run it on 2 different nodes. So here in that case on the Skylake node, and here on the Broadwell EP node, and the one does some AVX stuff, the other one tests AVX 512. And does some verification in the end. I have prepared something similar. Damn. So here you also see we have a Skylake job and we have a Broadwell job. Only the difference is, again, these script commands, they are using Python again and running these machine state. So we copy that, go to the editor, edit, the C configuration is valid, and let's run it. So we can check what the pipeline is doing. It's currently waiting. Here you see the both of the jobs. And if you click on it, you should get direct updates from the system. So you can follow your jobs on the fly. You know, this one is executed. The other one as well. So we passed both jobs. And we also see that here in the commit, there's here the green mark. So this is already quite nice. So we can run our tests on different nodes with different configurations, basically. So I could use a different Python module or do whatever I want on these two nodes. Okay, so as I said already, there are these stages in the Gitlab CI file. Here on top, you see the default stages as configured by GitLab itself. So we have a .pre stage, build, test, deploy is the main pipeline, and a .post stage, but you could define your own ones. So as you have seen in the editor in the beginning, you can have a stages keyword and then with dashed list of stages, and they are executed from top to bottom. So you can define your own stage. You can do something like build in between, or do some verification here of the binary before you do the testing stage, up to you. So what I do in the Liquid project is basically I use the pre stage to do some basic checks for the input file format, so like linting and so on. So in Liquid we have a list of performance events. It's a big text file for each architecture, and I check the format of this text file, for example, whether it's a valid format for Liquid to read it at compilation time. Then I use the build phase to set up the build system, build the whole thing, and store it as an artifact. I will come to that. That's why I have this slide here, the artifacts. And then in the test phase, I'm fetching the artifact again that I created here in the build stage, set up the runtime system. So that's also helpful because often you need some dependencies only at build time, but not at runtime. So with this separation, you can see that this is already compiled and should not need the build dependencies anymore, just the runtime dependencies. So that's why I wrote here runtime system and then run the application tests. In the deploy stage, I don't use that that often. I push the packages to indices like PyPy. So the machine state, for example, is pushed to PyPy if at releases. So why I'm showing that is the usage of artifacts. So if you want to have intermediate results from one job to another, you can store them as artifact on the GitLab server. So it's stored there. You can read it. You can browse it and so on. And you build some dependency chain by using job needs or depends. So here we see exactly that. We have a build job that builds on with an Intel system for AVX 512. And then we have a run job, which is in the test stage. And it needs stuff from this build job. Yeah. So let's look at the two parts again. So here we run on a Skylake node. We create it. And in the end, so if you don't specify an output name for compiler, it normally stores it in a file a.out. So, and this is the one that we specified here as an artifact. So, and we set some expire time. Please use some reasonable length. So a week is commonly fine. Normally you need the artifacts only in subsequent jobs and don't need to look at it later. So I don't need this binary after 1 week later. But there is, of course, there is stuff you want to store. So if you generate output files or whatever and store that as artifact, you don't want to have to expire. And then in the run job, we tell it that we need from this job the files, the artifacts. This will fetch all artifacts from this job. Since it's only one, it fetches only this a.out. With the pipeline, it is use this line. It's a recommendation. Add that always if you because if you start to create more complex CI systems, you will soon find out that if you have multiple pipelines, you need this pipeline ID all the time. And if you directly start with it like this, you don't need to manipulate all the jobs afterwards if you introduce new jobs. So that's very helpful. And it also helps you if you have multi-pipeline jobs, which use the artifacts from the others. Okay, so here we execute this a.out that we created here. So let's do that. Yeah. Prepared. GitLab, where's my? There it is. So there it is. I copy that to the pipeline editor. Then you can have a look on it. So this is a single job executed on Skylake, and it also runs machine state, but it creates an output file. So instead of printing everything on the console, it's writing it in HTML format to the command line, and we store this HTML file as artifact. You can directly see what the outcome is then if we run it. So come on, where it is. There it is. So job succeeded. And then we can see here in the pipeline here with the 3 dots, you can download the artifacts as an archive. If you go into the job directly that you are interested in, you can also browse it like here. We do that now just for demonstration purposes because it's an HTML file. And there we see the output of machine state. So it reads all machine information that is available on the system, like the CPU topology, and prints it in some nice form, which can be used for web pages and also as artifact description for papers and so on. So there's everything inside. You can even compare a system. So quite a helpful tool, but that's not what we are here for. I just wanted to show that you can use the artifact created by a job and look at it and so on. Okay. So it's getting complicated more and more. So for me in Liquid, the problem is that I basically need a job for every node we have in the test cluster. And I don't want to copy paste all that stuff here and just add this node list or change this node list. I don't want to do that on the fly. So that's basically it. So I want a job for each X, yeah. X like the system or CUDA that I also do. I'm running jobs for each CUDA version installed on the system or Intel 64 compilers. So you can create that yourself. And what you basically do in the main pipeline, so what is in your Gitlab Ci Yaml file, you have two jobs. One generates a pipeline and the other one starts it. And at that moment, it creates a child pipeline with all the jobs we have dynamically created. Here is an example for that. So that's the generation job here. We run it on the test cluster again. We don't want to have a Slurm submit because we want to run on the test cluster. On the compute nodes, we cannot find out what are all the other compute nodes. We have to do that on the front end. You can get that with the no Slurm submit variable. And then we execute a shell script, which creates basically this YAML file, which is compatible to this Gitlab Ci YAML. So it just contains jobs, and we store this file as an artifact. And in the end, and afterwards, we create a pipeline job which for execution, and it uses this trigger here, and tells us download from this archgen job this archpipe YAML. We are depend on that and trigger this pipeline with it. Yeah, it's a little bit complicated in the beginning, but it's quite handy. And I have like 4 or 5 of those parent-child pipelines already running for Liquid. If you want to create in the main pipeline additional stuff like build the binary or whatever, and use it here in the pipeline, in the child pipeline, you need this parent pipeline ID equals CI pipeline ID. And that's basically also why you need this in the previous example with here the pipeline. That's basically the same thing. So we tell that it's in a different pipeline, and this is the ID. Yeah. So let's do that. I have now it's getting a little bit more complicated because I need to create folders and files. So create a folder. So this, and then we add a file. So I have prepared already the shell script. So that's needed. That's basically it. Basically, we do a module avail to show us all the Python modules that are available on the system, and do some manipulation here. So we don't want to have the dashed lines and so on, and we want to have just the version. And then at this stage, we write out the YAML file. And since you have seen the YAML files from before, you can see that's basically the same thing. Nothing changes. We use the variables here, like the module, and some manipulated modules. So without the slash, we delete the slash and replace it by a dash in this to create the name of the job, and we store some artifact. So that's basically it. You can test that on your own before you really submit it to the CI by running it on a compute node or on test cluster or on the test front or whatever. So we copy that here, and store it. Yep. So now we go to the editor again. I hated Xcode. This is basically the pipelines. So it's similar to the ones on the slides, but this one with Python. And we don't care whether it's submitted to a job or not, to a cluster node or not. So it's even recommended. to use the modules which are really on the compute nodes and not on the front end. So, and then we run this script we just created. Since I'm not able to change the executable permission right now, I'm using like this. So, and then we store that, and then here in the test stage, we start that one. So let's copy that. So it's a valid configuration. And then we go back to the pipelines. And there we see the two jobs. So first the generation job, which generates all the children jobs. And as soon as this one started, we should see, yeah. So this one is then triggered, and creates this child pipeline. And there we see the automatically generated build job, so build and then the Python dash version, and we can also look at it, and we can see that here we can use again the artifact to look at it. Yeah, so this is a quite handy feature, but a little bit difficult to set up, especially that you need some separate shell script in your repository. So I tried to come up with a solution for that. And this is basically multi-line commands in this Gitlab CI. So if we don't want to have this shell script in our repository, can use something like this. I was not able to use cat EOF because EOF is a restricted keyword in GitLab. So I had to use this chain of echoes. But this is basically creating the YAML file. If you work with the shell, you will see that. And we pipe that all to this Python pipeline. And with this is executing exactly the same stuff as the version before. The important one is that you have to start your multi-line command with dash and then the pipe. And this tells GitLab YAML or YAML in general, I don't know, that it's followed by a multi-line entry. Yeah, so this is perfectly valid. And you can fire that up. You cannot see any changes to our previous run because it's exactly doing the same thing. So we also get a Python gen job and a Python pipeline job, which is executed as soon as this one is done. Okay, so this is what it looks like in Liquid at the moment that I created this slide set. So what I basically do, I have 3 jobs which build the Liquid library and install it locally under the CI folder and store it as an artifact. There's a question. Ah, yeah, okay, yeah, it might be. I've just tried it like 5 minutes. So cut EOF seems to work if you take care about the intention. Yeah. So I build these jobs. I generate 1 job for each cluster node in the test cluster. And or basically multiple jobs, because I have, like, for x86, Liquid provides 2 backends, and I want to test both backends. That's why we have 2 jobs per node in the most cases. The CUDA pipeline is also generated, and runs for each CUDA module that is installed on the test cluster. Yeah, and you can have like a lot of these downstream pipelines, yeah, to run your checks. This is I don't know why it is moved here, but yeah, this is basically probably some copy from the previous previous slide. Yeah, so this is for each node. So if you run it on each node, use an S8 info. So with this, you get just the file, the name. So jobs minus host. So here you get jobs Broadwell, jobs Skylake, so on, and then do your configuration. Here, this is the example for the whole CUDA module thing. It's basically the same as the Python example that I have shown. So we run module avail, do some manipulations here, replace the slash with a dash, and use the variables when creating all the jobs. Now there's a feature which is not available at the moment directly from us, but in collaboration of the LSS, we had this NHR project about CX, or still have it, and they wanted to have continuous benchmarking for the Valhalla software framework, which is a quite big framework and has a lot of different features, a lot of different backends, algorithms, and so on. And there's a lot of work going on, so there are a lot of commits and a lot of branches and so on. So they want to keep track if somebody commits anything, whether this has changed the performance of their of the framework or specific runs. What they do basically in the end of the script, they push the data, some performance data, to some InfluxDB database. InfluxDB is a time series database, so made for time series based data. And for the visualization, they use Grafana, and it looks basically like this. So you get, for each of the commit, you get a dot and the performance of the code at that CX run. And then you can directly see here between these two commits, the performance, or the runtime went down, so got a little bit faster for these two kernels. Yeah, so this is just an what you can do with continuous benchmarking. Currently, it's not provided by us. So these InfluxDB and the Grafana server is currently maintained by the LSS Valhalla team, but we are in the making to do something similar with like less external services, hopefully. But as soon as we have that done, it will be documented on the CX webpage. Continuous deployment, I do that really rarely. So because Liquid is not, there's no way to do that for Liquid. So for releases, in this case, or tags in my case, I uploaded the tested version to a registry or install it on a local server system. So I could think of a nightly Liquid build, which is directly pushed to the test cluster every night, something like that. Check out the GitLab repository documentation for that. They have a lot of helpers for package registries. The recommendation is to put all the account names and keys as variables in the CI configuration of the repository, as we did it with the username and the private SSH key, because then it's not visible in the script. That can be read by anybody who has access to the repository, but only to the maintainers of the GitLab side. So it is some access restriction. We do that, for example, for a Julia project, which uses some additional deployment stuff. I could show that. So the summary, we provide a CX infrastructure for HPC relevant CI. So it's not meant for, so you can do that, but it's not like a lot of container running and so on and doing some Node.js testing. It's definitely not meant for that. It's running on pure hardware. So it's meant for testing code that requires specific hardware features. You can use it from gitlab.rrze and gitos.rrze. Other GitLab instances won't be allowed. So even in the future, we have talked about that internally, and we decided to stick with those two, especially since you can use this syncing feature without a problem. After syncing, it's also available for external repositories. As we have seen on GitHub, you see that in the testing list, you see the CI on the GitLab, on our GitHub. We don't have any virtualized environments. I thought about that, and I'm working about that to have some kind of singularity containers, but it's far away from getting any live. And also install everything below CI project directory and clean up in the AfterScript part, and use artifacts to reuse job results. So happy testing, everybody. This is like, I've listed some use cases just for you if you're thought about like, is my software project like suitable for it? So that's what I run with it. So I'm even testing accelerator code, running GPU examples on NVIDIA GPUs. I'm not doing performance tests yet, or I'm doing performance tests, but I'm not storing them in some database for plotting. And we can run shared memory codes. It's the test cluster. The nodes are interconnected with some Ethernet, but it's not meant for MPI jobs with a lot of communication. We can think about that in the future to have a GitLab runner for MPI jobs, like on Maggie or something like that. But it's like I have to talk with the admins, so that's a that's a claim I set up now. Not sure whether they would allow it. We'll see. You can use it to build simple LaTeX projects. So if you use, if you write a paper, you can use GitLab and use the CI to build the paper, store the PDF as an artifact, and you can download it every time you committed something. That's it. Any questions from the audience? Speak up or just write it in the chat. Yeah, sure, you can run your own self-hosted runners, but then you probably have the problem. So the test cluster nodes have no internet connection, and also the other cluster nodes not. So if you want to download anything, you will get a problem. You have to do that on the front end, then log into the cluster node and do that in a custom self-host runner. Is possible since we did it the same way, but it's not that trivial again. So besides the slide set you have seen right now, as I said, I've created an additional slide set just with like the way to go, how to sync it, how to sync a repository and so on in a separate slide set. Looks like this. So there you can just see, use new project, press this button, go to GitHub. Here, how to generate a new token. Here also with comments and so on. And also how to configure a repository to use the NHR FAU6 services. These both will be downloadable at the HPC Cafe page.